this is Idam, and today's lesson will be about interfaces, exception handling, and finally. In this video, I will be defining an interface, implementing an interface, using an interface in the first half. Then I will go over the default handler, try and catch in the second half, and teach basic try/catch/finally, finally without exception, and try with family as the last section. As mentioned before, the first topic is about interface. Interface means an abstract class that is used to group related methods with empty bodies. In order to access the interface methods, the interface must be implemented by another class with the implements keyword. And the class that implements the interface needs to provide code for all methods in the interface. In the example below, we see that there is a class defined as circle, which is followed by the keyword implements. And the implements keyword is then followed by drawable. To make things simple, the circle class is implementing, or also known as executing, the interface drawable. And the lines 2 to 4 provide implementation for the draw method in drawable. Next is all about using an interface. A couple of things to keep in mind when using an interface is that an interface cannot be expressed via the new keyword. It needs to be used via a class that implements the interface. For example, we have a class called ShapeDemo that used the class circle from before. In line 4, we see that a circle object called circle is created and invokes the draw method. Then we see a drawable variable called shape, but assigns it to a circle object, which does not cause any compilation errors. And we see that line 9 invokes the draw method via the shape object. This will then output invoking circle.draw, drawing a circle, and invoking shape.draw, drawing a circle. Moving on to the next topic, we have exception handling, which refers to Java's mechanism for handling errors that occur when code is executed. In some cases, Java creates an exception, which is an object of an inbuilt exception class, and throws it. Exceptions need to be caught and handled, so Java has a default exception handler that handles exceptions not handled explicitly by the code. The example shown has a class named ExceptionHandlingDemo. In line 5, we can see that it tries to access the element at position 5, but the array size is 3, meaning that position 5 does not exist, so the code does not cause a compilation error since syntactically it is correct. Instead, it causes an error when the code runs. Next we have try and catch section. Java provides the try/catch keywords, which can be used to explicitly handle exceptions in code. We have the basic try-catch, where the try block allows specifying code that needs to be monitored for exception, while the catch block allows specifying code that needs to be executed. As for multiple catch blocks, any number of catch blocks can be specified after the try block to handle different types of errors. And for try without exception, the code within the catch block does not get executed if an exception does not occur. The next couple of slides are examples of these try and catch blocks. Here's an example of a basic try and catch block. We can see here that line 4 specifies the try statement and lines 5 to 7 specify the code that needs to be executed. Lines 9 to 11 specify a catch block that handles an array index out of bounds exception. Here, E is an object and has several methods that provide additional information about the exception. Then the catch block simply specifies a print statement that prints a detailed error message. If you run the code, it should print unable to access array element 5. Done. This is an example of multiple catch blocks. Lines 5 to 9 specify some code within a try block, while line 9 divides value by 0. Since dividing by 0 is invalid, line 12 causes an arithmetic exception. Lines 11 to 16 specify a catch block, so this code will output element at position 5, 3. Division by 0 is not allowed. Done. And last but not least, we have a finally block. This block can be used to specify code that needs to be executed always. In basic try/catch/finally block, the finally block follows the try/catch block. It consists of the keyword finally followed by code in curly brackets. In the example below, we see that lines 4 to 12 specify some code on a try-catch block, while lines 12 to 14 specify a finally block. This code will then print unable to access element at specified position in finally. Here we have finally without exception, where the code within the finally block will execute even if an exception does not occur. In this example, lines 4 to 11 specify some code in a try/catch block, and lines specifies a finally block. This code will then print element position at 2, 3 in finally. Next is try with family. The family block can be used even if there is no catch block. For example, the code below has specified code in lines 4 to 9, and the try block is followed by a finally block at line 9 with no catch block. This code will print out in finally and show an array index out of bounds exception since there is no catch. And that was all about interfaces, exception handling, and finally.